Aviation Maintenance Publishers presents Propeller Care with your host, Jim Reedy of Hartzell Propellers.
Today we'd like to spend some time discussing propeller care. Propellers, like automobile tires, demand a certain amount of care. Your automobile cannot operate without its tires. An aircraft cannot operate without propellers. We'll review the removal procedures of a propeller and then follow this propeller through a repair station, reviewing the necessary procedures to return a propeller to an airworthy condition. Here we have Robert Rock removing a propeller from an aircraft. Robert is the shop supervisor for Aero Propeller Incorporated of Broomfield, Colorado. To remove the propeller, you simply back out the propeller attaching nuts, backing them out on a rotation basis. Pull the propeller forward. As the propeller is pulled forward, it will come away from the crankshaft. Once the propeller has been removed, it is necessary to see to it that no contaminants get into the crankshaft, so this crankshaft area should be plugged. In this area of the propeller shop, Rock will be disassembling the propeller, and what we do is disassemble the propeller completely, meaning we remove all parts, one from another, that are in the propeller assembly. It is necessary at this time also to check the different areas of the propeller for wear. For instance, if in this propeller, the rod will have to be checked in certain areas for wear. If the rod is worn beyond its minimum clearances, it will have to be replaced. There are a number of other parts in this particular propeller that also must be checked for wear. For instance, the fork, the area inside this fork must be checked, as the threads in this area will be checked for wear and whether or not the part can be reused. Also in this propeller are two bearings, two loaded bearings. These bearings do Burnell if adequate lubrication is not present, and if that Burnelling cannot be removed, the bearing will have to be replaced. One of the next procedures that is performed would be the dimensional inspection of the propeller blade. The propeller blade is checked at each blade radius station, meaning a certain number of inches from the center of the hub out. A station is established, and it is that point where each blade is to be inspected. At each station, the height of the blade off the table will be inspected to establish face alignment. The width of the blade and the thickness of the blade will also be checked as the track is checked. The blade angles at these stations also must be established. If the blade meets all the minimum requirements, the blade can be returned to service. However, if the blade is not wide enough or thick enough, it will have to be retired. The next process in the propeller overhaul procedure is to test the parts for cracks or inclusions. What you're viewing here is the process of dye-penetrant inspection using a dye-penetrant method. The part is dipped into the dye, allowed to drain, then washed off using water. Once the part has been washed, it's placed in a cabinet and allowed to be air dried. The part must be completely dry and without any over traces of the Zyglo material. It's then placed into, after it has been dried, it's placed into the developer tank. The developer is allowed to dry and will dry to a powdery white type surface and then be placed under the black light to check for cracks or inclusions. The second part of non-destructive testing is to magnetically inspect the part using a magnetized piece. The piece is placed within this plate, magnetized, flooded with materials, and inspected under the black light above. The second method is to take the part and place it in the large coil, again magnetizing the piece, flooding it with materials, and checking it under the black light. The two processes that you've just viewed are required at TBO and cannot be performed by the mechanic himself in the field. It is necessary to regrind the blades or remove enough material from the blade surfaces to remove corrosion or any nicks or scratches that might be on any of the surfaces. This process must be performed on all surfaces of the propeller blade. Following the grinding process, each blade is buffed using a soft buffing wheel which tends to blend in the scratches placed in the blade by the blade grinder. Once the buffing process has been completed, the blade is now ready to be anodized. There are two chemical processes involved in the overhaul procedures of propellers. Number one is to cadmium plate all steel parts. Cadmium plating is a coating applied to the steel part which prevents rust or corrosion. Once the part has been cadmium plated, it is removed from the solution and baked in an oven from 2 to 8 hours at 375 degrees Fahrenheit. The second procedure used is anodize. Anodize is used on propeller blades and hubs. The blade is dipped into the anodized solution, which is chromic acid, and allowed to remain for a period of time. The solution coats the blade with an anodized surface, which acts in two different ways. One, as a protective coating for corrosion, and the second, as a crack detection procedure. Any propeller blade that has not been anodized will corrode in a very short amount of time in the field. As you can see in the blade, there is corrosion in this blade, and this would have to be returned to a propeller shop for overhaul. Any propeller blade found in the field without a protective coating of anodizing or Polane paint will require removal from the aircraft and return to the propeller shop for overhaul. This propeller has just about completed its full final assembly conditions. We're taking the blades from the feathered position into low pitch. The lubrication of the prop has been completed. All torques have been applied to the various bolts. We'll now set the low pitch stop, charge the cylinder with air, and once the cylinder has been charged with air, the propeller is ready to move on to the balance area and the final step of propeller assembly. The final process in propeller assembly would be to final balance the propeller. These blades have been pre-balanced, meaning that they've been matched to one another prior to the time they were installed in the hub. At this time, the propeller will be balanced, adding weights as is being done at the present time. The equipment that you see is very sensitive, and it is necessary to have this type of equipment to assure proper balance when the propeller is reinstalled. There is one other method of propeller balance, that being dynamic balance, which must be done on the aircraft with the propeller rotating. We're finished now with the overhaul of a propeller. The propeller now may be installed on an aircraft or shipped to its final destination. The videotape that we'll be watching at this time indicates the natural frequency of a propeller blade. In mode 1 of propeller operation, the propeller blade will be bending 1 time. If you watch the tip of the blade, it will begin to go into resonance. At this point, the propeller blade is bending 1 time. To find the point at which the blade is bending, what we must do is sprinkle sawdust across the blade, and as you will note, it is at this point where the blade is bending. If a nick or scratch should be present at this point, it is possible to have complete blade separation. It's for this reason that we ask for adequate propeller blade care. In mode 2 of propeller operation, the propeller blade will be bending at 2 different locations. You will note again that the tip will go into resonance. We will again use sawdust to try and find the points at which the blade is bending. This being mode 2 of operation, the propeller blade will be bending at 2 different locations. You will also note that the propeller blade is bending in different locations than it did during mode 1 of operation. The nodal points being approximately 12 inches from the blade shank and 10 inches from the blade tip. In mode 1, we had the nodal point approximately 15 inches from the blade tip. We'll now use a strobe light and repeat mode 1 of the propeller operation. With the strobe light at the tip of the blade, you will note that the propeller blade is now once again going into resonance. This is the natural frequency of the propeller blade and is not overacted or over indicated. Again, in mode 1 of operation, the propeller blade is bending at 1 place. You will note that if a nick was present along the leading edge of this propeller blade, it would be quite possible for the blade to separate. The natural frequencies being produced and transmitted into the propeller would cause separation if a nick was present on the leading edge. Under mode 2 of operation, again, using the strobe light, you will note that the propeller blade is bending in 2 different positions. The strobe light in this instance is on the very tip. It will be moved around to the leading edge. You will be able to see that the propeller blade is bending in 2 different locations. It is possible, as the RPM is increased, for a 3rd and 4th nodal point to appear on the propeller blade. Using a pointer, you can see the propeller blade bending at its first location and once again at its second location. Again, the point to stress is that if a nick or scratch appears at any of these locations, separation of the propeller blade is possible. As demonstrated in our lab sequence, you can see by looking at this propeller blade, a nick on the leading edge of the blade has caused this blade to separate. If this nick had been removed properly, the blade probably still would be in service. As demonstrated in the lab sequence, you'll see that the lines of resonance coming out of the propeller hub area itself from the engine are transmitted through the blade to the blade tip. If this is your nick, and as you can see at the bottom of the nick is a crack, these also being small cracks in the material that has been damaged. This material must be removed. All this material in this area will be removed, and once that material has been removed, your repair will look as this indicates, with the lines of resonance coming out from the hub, going around the area that has been repaired and out and being dissipated off the propeller blade tip. Well, now I'll demonstrate the proper tooling required to remove this nick from the propeller blade. To start with,